All right, so, whoa, where'd it go? Oh, here it is. These are one of the problems that takes me time to think as well. These are not easy problems for, I think, almost anybody. So it's hard for me to write and talk at the same time. So I wrote it out and I'm going to try to explain it to you. So what we have is we have a sequence, and they're saying that this sequence is equal to this expression right here. Let me try to highlight as I go maybe. But I want to do it very, so we're trying to prove this guy, right? That when you add these up, it equals here. So we have to prove it, in the proof of induction states that we have to prove it for 1. So when you put 1 in here, you get 1 times 2 times 3 divided by 6, right? That's what this part right here is saying. And that should be 1 squared, and that's true. So we showed it was true for the first case, we did that. All right, now we need to show it's true for any value k, which in a way is just replacing the n with a k, right? We're showing any number k is going to work. So we put that, and we just put a k instead of n squared, we have k squared, and we have that here. All right, so now we need to say, we're assuming it's true for any value k. Now we need to show that if we were to take, let me try to write this. If we were to take this expression here and put a k plus 1 everywhere for k, right, that it's going to equal when we take this side, right, when we take this side and we put a k plus 1. So we put in this k, we put a k plus 1. And it's going to equal this side if we were to put a k plus 1 everywhere. Right, so let's see what happens here. And we know that this part I have here in green, all of this equals what's here in green, because we just said we're assuming that part is true, right? And then we're going to put in this k plus 1 squared. And here's where you kind of just have to do some clever algebra. And I did this down here for you. All right, so we have this k plus 1, 2k plus 1. We have this part, right? That's just a repeat from up here. And then we're going to say it's k plus 1 squared. And I wrote it out as k plus 1, k plus 1. And then what I see is, oh, I need to find a common denominator, because if I want to add this expression to this part, I have to have I need a 6 down here. So I go ahead and say, okay, I'm going to have to multiply k plus 1 times k plus 1 times 6. And that gave me the common denominator. And now I can say, well, can I do something with this whole numerator? Can I do something with it? Ah, yes, I can, because there's a k plus 1 twice. So I'm going to factor that part out and put it in front. And that's going to leave me with this expression, to which I can simplify this part, right? I can say k times 2k, k times 1. And that brings me, I just was showing you that that's how they got this part up here. All right, and then it's pretty straightforward what they're doing there. They simplify the inside, right? They just keep simplifying down. And then at the very end, they have this simplified. And if I took a k plus 1 everywhere, then I'm going to end up with the same as if I put a k plus 1 up here. All right, this is a pretty hard one because of the algebra. But I'm not too picky, I think, because you already took the test, you saw, I really want you to be able to show that you proved for the first, right? You're proving for the k, and you're trying to work the algebra of k plus 1. But this will be something that if you go to higher level math, you'll get to practice again, as it's very complicated.